Tony, welcome to the QTS Experience.
Hey, no, thanks for having me. I appreciate it.
There's so many topics we could talk about. Like we literally kicked around a dozen, and every time we start talking about one, we almost have a mini podcast. We start taking off. Today, we're talking about networking. Our audience, we're going to have links to you and to your newsletter down below, and your role. Very interesting career as a commander in the Navy and now in the data center business. But we chose networking. And of all the topics that you suggested, I was like, why networking? And you said, well, man, why networking? I thought we were going to talk about something glow in the dark or something crazy. Why do you think we should talk about networking today?
I think networking is important because I think it's overlooked a lot. I mean, I think that's the way the clouds think when they look at deploying. It's the networking. They make sure they have to diverse or try even three routes, and they look for diversity in providers. But that dictates where they deploy their data centers for most things. And we're going to set LLM aside, AI LLM, because that can really kind of be anywhere.
Mm-hmm.
But the rest of the stuff it's based on latency. It's based on basically affinity or non-affinity they have across their parent and child sites. I mean, there are reasons all those distances are there, and it's all based on networking. And networking is also what people really care about, because since everyone's going to the kind of multi-cloud, hybrid cloud solution, it's, where the peering and on-ramps are,
Yeah.
which is really where you get, where the money is. And to me, whoever has that peering and on-ramps really are the center of the universe.
I want you to dispel then something for me. I love this. And I'm sure you do as well. I attend a lot of events. I listen to a lot of events, even the ones that I don't attend, in our industry or adjacent to our industry, telecom being one of them.
Yeah.
And one of the things that I've heard a lot in the last 2 years, again, setting machine learning and AI and that sort of big learning bucket aside, whether it's primarily in hyperscale data centers or even some of the smaller enterprise. Let's just pretend that doesn't there. But even with that set aside, where they've said, we really don't need the emphasis on an availability zone, the emphasis in having connectivity that looks like this is just not there anymore. Now, I am not versed enough in that, in my experience or in that discussion, to know if that's true or not. I don't know that I've had any customer tell me that directly, but I've heard it a lot at these events. And it seemed like what you just said was, well, hold on, there is still a real sensitivity around latency for a majority of deployments. There's still a real sensitivity around where these environments need to be deployed for a variety of reasons. Are we misunderstanding it, or are we misapplying this idea that availability zone or close proximity, because availability zone also infers a certain level of resiliency. It's not just a latency. So if somebody were to say that to you and we were having a tasty drink of one sort or the other, and you wanted to help me understand what I'm getting right or getting wrong, how would you react to that?
But I don't think you can say that. I'm curious who is saying that the zones kind of don't exist anymore, or the distances don't exist, because they do exist, and they're based on really a platform, and that's super hard to really recode that platform. So, for example, if you have a parent site, that's typically where your main let's say software platform is deployed. I mean, in a platform might have like let's say, OCI, because this is what I know. That platform might have, 220 different distinct apps on it. And the way they, deploy that main piece of data, that main software, and the way they push that to child sites is different. So, you might, just because you have a child site doesn't mean you have that piece of software deployed on it. It might replicate from the main site. So that's, kind of the affinity versus non-affinity. Affinity is you have the same thing across all the sites. They don't really do that. Most, the other way is not, where they don't have that affinity, where you have the main program in one of the zones, and you have, kind of just a lower version of it, a way to get to that main program, maybe where the data is at on that other child site. So it really depends on how they architect the platform, but there's also a lot of resiliency in that too. So there's a replication across it too. And, if you look at FinServ, the way they, timestamp their data, I know kind of that kind of stuff really matters on distances and latency. So they could be right in some perspective, but I don't know how you would have that distance. One way I can think of distance really increase, and it's really with hollow core fiber, which is gets you 30% roughly more distance with the same latency, just because it's hollow core as opposed to solid core glass. Hopefully that answered your question.
No, I'm right. My mind is just buzzing. Two quick things. I get three quick things. One, I probably should have said in all of these conversations, it was in future deployment. So not existing legacy or existing platforms. It was next gen platform, next gen deployment. And maybe it's always, and it wasn't obvious to me, in the context of an AI ML deployment. I don't think it was, but it could have been. And before you answer that, hold on, I'm going to give you a chance, I promise. Yeah. But here's the other thing. You and I, airborne guy, I have a lot less acronyms. Navy nuke guy, a lot more acronyms. But we still are acronym-centric. And we're in the data center business. We love our acronyms. So some of our audience doesn't know any of these acronyms. When you say FinServ, what does that mean? And at some point, if you could take a second to explain, and I mean this with the smile on my face, somebody once said to me, what do you mean dark fiber? What's dark fiber? So hollow core versus solid core, if you've got a second to tease that out. But acronyms, I'm going to every now and then remind you when we use an acronym, because I'll use it too. Let's say what that means. What is FinServ?
Yeah, FinServ, financial service companies.
Okay.
Anyone that has a bank or could be doing credit on that. I mean, they're interesting because it's throughput. It's not necessarily data, and it's the timestamp of that throughput. Imagine, millions of credit card transactions going through. So it's a different problem they're trying to solve for.
Gotcha.
It's not necessarily, the data problem. It's this throughput for all these things, but also they have to make sure they get it right.
Right. And then hollow core versus solid core, what does that mean?
Fiber wise. So normally when they put fiber on the ground, it's solid core fiber. So it's glass all the way through, and that has a certain distance on it that you can go before you start losing. I mean, that's why they have, kind of regen sites and everything. Mm-hmm. But you can have this, it was made out of a college out of Britain or UK that developed this hollow core. So it has like this air inside the hollow core. So it's really is just like a glass with another hole in the inside of it. So they can get a lot more distance out of that because it's in air and not in glass. And still have the same kind of latency that you have. So it basically extends your capability out like 30 or 33% more distance with the same latency that you would have. So it gives people capability to go a little bit farther out there. And it's that kind of stuff's important because a lot of these sites, they've already taken up all that SIMs around it. And so if you could push that out a little bit further, it gives you a lot more capability to select sites for new data centers instead of really, we can only go to this site. Now you may be able to go to this site, or this site. Right. And you wouldn't have to change any of your platform. So the platform would be exactly the same. All you're doing is changing the internal fiber of how it's routed.
So when you think about, I love how you lead, especially somebody like me with this provocative thing. I want to talk about all the problems, especially with networking, that these verticals are having, DoD, federal enterprise, is because I can think of a lot of challenges. As it relates to networking, and you're talking about, is that the primary problem? Expanding the sphere? Is it access to infrastructure? Is it the technology? As we're bumping into Shannon's law, when you're in your role now, but also just as a concerned citizen of this industry, can you tease that out for us a little bit? Help us to understand what you mean by that.
Yeah, but I think, data center industry, we tend to think of where I can get that site that's relatively cheap to buy that land that has the power that provides. But as someone who looks at cloud as well, or used to build that stuff, you also look at, kind of what networks are there, what providers are there, how many diverse routes do you have? Where's your customer at? What latency does your customer want? What kind of, do I have, like if I'm Oracle, can I also have an on-ramp to Microsoft right there because we had a partnership with them? So, it's all about these pairing and on ramps and latency that these software, when they develop these platforms for each individual service, they have to use some bounds on that software piece. So, they can't just go anywhere. And then if you try to change that, that's a total re-architecture of the base platform. And the problem is it's cascading because a lot of services have dependencies on other things.
Right.
So when they start monkeying around with one service, you tend to affect a bunch of other services. And this is why that the mythical thing of you push a button in a cloud automatically deploys, it's super hard because there's hundreds of services, hundreds of teams operating independently of each other. The dependencies are murky on which services they depend on. And so it's awfully, it's like a clown show when you deploy these, and it's no fault of anyone. It's just hard.
Yeah.
Because you're typically calling teams in to troubleshoot and code is changed. It's just hard. And, God bless those people who do that kind of stuff. They're like the unrecognized heroes of, these cloud organizations. They work tirelessly to deploy these regions. And since they aren't developing new code, they don't get the respect that they should get because they're enabled what makes the magic happen.
In some ways, it's almost I remember conversations back in 2010, long time ago. We first of all, I remember when we never thought production, much less anything with the federal government, would be in the cloud. Like that would never happen. It'd be a test dev, QA world. And we had a product that was long since gone in our world of a private cloud. And when we learned how difficult, not only to work with the cloud providers to get an on-ramp within a site, but all of those things that have to happen, all the orchestration that you have to help manage of the folks that bring the connectivity, the apps themselves, the platforms that we have to make. And we weren't, and it is in my conversation sort of going forward from probably, 2018, 2019, somewhere in there, because in our world, we're providing the facility, but we're really not in that service business anymore. Yep. We've long since allowed the public cloud, and even those private cloud folks that really do it well, we just don't compete with that anymore. We've moved out into a more focus in other focuses. Yeah. But this is what it reminds me, because it was always about a rich, fertile soil, not just of availability, but the right availability, and not just with latency, but my providers are there, my on-ramp is there, my orchestration layer is there, my diverse paths are there, wherever there is. And it was as important as site selection criteria as permitting and financing and anything else.
Yeah, go look at when you select sites, the network team gets in, they look at their little Google Earth, and they look at all the fiber routes, and look where it goes. And, all that stuff, it's not straight line distance either. It's the fiber route, the fiber distance of length that it's traveling, not as a crow flies, as it goes around easements and properties and other things. You might be 2 miles away, but have 14 miles of fiber that you have to deal with. So, I think it is something that we as in the data center we don't think about because we don't have to. But I think if you're trying to figure out, especially in my business, where your piece fits into everything, you have to understand the networking needs of the customer, because typically that's how they get to their customer. That's how the person selling their service gets to their customer. And that's why bandwidth charges are the way they are, throughput charges are the way they are. All that kind of stuff matters. And that's this whole concept of data gravity or artificial data gravity, which is basically, data tends to stay in one location because it's expensive to move and it's really heavy and everything goes to where that data is. But the artificial data gravity is that you put stuff in the cloud and it stays there because it's too expensive to pull all that data out. So, it's you move the compute to where the data is. Yeah. This is the whole premise of it.
I actually did a presentation at PTC about 5 years ago about data gravity, and at the time, and it wasn't a new concept, right? I can't remember what the engineer out of GE's name was, but it's been around, and now it is, in whatever way we thought it was in force 5 years ago, it is exponentially more in force now. You have forwarded this idea of network as a service. What do you mean when you talk about that? What do you mean by network as a service, and what role would it serve to these customers that you're trying to serve?
I think it's it's this idea as these, kind of network teams, what they would do is just basically lay the fiber and that's it. But now they're starting to get into this, of multi-tenant, multi-provider solutions and using a software layer like a marketplace. So you can, in theory, have your pick instead of you having to solve it. You just go to the network company, they have a marketplace, and you say, I want this company and this company. And, the software orchestrates the platform for you. So it's this concept of where you're going to have the network provider route your bits for you and like through private fiber as opposed to all these other fiber routes that we have. We don't have that many east-west or north-south fiber runs. And this in the United States, for example, now, the United States is spending roughly $77 billion on pushing broadband to rural areas. So that really opens up more fiber routes. It pushes internet exchanges out of traditional areas. So you might go from no real on-ramp to having 200 on-ramps in a state because you have all these new IXPs funded by the government out. So now you're going outside traditional areas, you're peering on-ramps outside of those areas. To me, that's kind of where the center of gravity is, where that peering on-ramps are. So where's the compute going to be when you start moving those points? I mean, there's a reason why everyone goes to the internet exchanges in these cities like 60 Hudson and everything. But now you're going to have multiple ones because they're going to have their own private fiber network, and you route it. It's like an software-defined wide area network solution that route the bits. So that's kind of this premise of network as a service. Instead of you having to figure it out, they've already got the software, they've already got the network pass for you, and and you pick from the marketplace what you want, and they take care of it for you. So they provide that service, and because they're doing it and they're doing it in bulk, they're probably going to be able to do it cheaper. And they'll be ahead of some of these other groups that are trying to individually do it because they're more spread out. Hopefully that makes sense.
Oh, it does. In fact, I mean, I'll just ask the questions because my mind's going a million miles an hour. So. First of all, is there a momentum? I absolutely understand the need as you're describing it. I completely agree. I mean, it's, but is there a way? We talk about a lot of things. Is this an idea that's way ahead of its time?
No, I think it's always been there. It's just the problem with Edge really is the need is there, the network is not.
Right.
And so now you have more companies consolidating networks. I mean, look at, Colt bought Lumen in, Europe and now has 70% of the network. That gives them the capability to really kind of take charge of how they route the network bits. So, and think of this software defined network as you don't have to. You can just go to them and they can offer the multi different fiber providers or route your bits and make, your distance that your stuff has to travel less. So it's better for the customer. So they take care of it for you. It's the as a service, I think the only one who's really kind of announced that concept is British Telecom, but I think you're going to see more and more network providers really kind of offer that marketplace and that software defined network in the future, because to me, that's the center of gravity. I mean, I get the whole idea of data, but where your on-ramps and where your peering points are, and on-ramps are to different clouds, and, where your peer with, is kind of the center of gravity to me. And that's that's why internet exchanges, everything built around that. Now you have hundreds of these funded by the US government. This is the United States,
right?
That you're going to have to put compute around.
Right. And usually they're in areas where it's very difficult, even if they had space around them, to get into these legacy facilities. I remember when we converted our battery room in one of our data centers because it was an old telecom. Our heritage is out of ELEC in sorry, no acronyms. A regional telecom area, and so it was 100 watts a square foot and blah blah blah, all these other things, and so the infrastructure is not there to just easily expand them.
No, and I think it might actually be the right time to do it too, because I think this old telecoms infrastructure that was built originally for roughly 2 to 3 kilowatts per rack position is being stressed immensely to get the standard compute, which is around, peak of 12 kilowatts, average around 6 to 8 kilowatts. Now we're getting higher density stuff, and peak is probably around 40 to 50 kilowatts now.
That's right.
They could barely handle 6 to 8. So new infrastructure will be needed to handle these new rack loads. And if you already build in this new network that's funded by the government or consolidated by companies like Colt, then maybe the time is to deploy new infrastructure to take advantage of that kind of stuff. I mean, retail is already, I think it's less than 4% vacant right now. I mean, and they're there because they provide you a good service and data centers where you need it. But now, and they're close to those on-ramp clearing points. But now you have multiple, on-ramp clearing points, and you're going to have multiple points for that on-ramp and peering. So, it takes a long time to build this infrastructure.
Yeah.
To be able to support that.
I love that you said that number of 4% because somebody I heard earlier this week, the week that we're recording this, that it was about 3%. And whether it's 3 or 4, that's essentially no space. I mean,
there's no space. There's no space. So imagine you're a retail company, and a lot of retail's having the same, like these enterprises and DoD for that matter, all having the same problem. Rack densities are getting more dense. They shoestring outside air conditioned split systems to get to 6 to 8 barely.
Right.
They even have data center people fanning this stuff, and now you're going to 40 kilowatts for LLM, or maybe 20 kilowatts for inference. I mean, that's still debatable what that's going to look like, but it's going to be super tough to handle that kind of stuff. So how do you do that kind of stuff? So I think that it's going to be interesting. And I like to do kind of a reattack too on the network stuff too. One other thing on this whole concept of DR, but it's also, how do you make sure your customer is not impacted? You need to give them the capability to deploy across 1 or 2 regions, and the regions need to be far apart enough where an outage won't affect that. So they still have another AD that they're deployed on, so they don't actually lose their service. Now, does anyone do that? Not really, because it's far cheaper just to deploy one service and write a trouble ticket if that AD goes down. But that was the whole idea of multiply, that the customers will use those to deploy their services, and there's replication across that, so the distance does matter.
Right.
So sorry, don't mean to confuse the previous conversation with here, but I want to make sure that comes out too, because there's a lot of variables that go into the distances.
It's complicated because there is, for the longest time, I mean, we would listen to thought leaders that would say, because when they came up with these ideas, it's 15, 20 years ago. And so they were like, look, what is available to us in terms of, the optics only had a certain performance. Ironically, we're reaching the theoretical edge of the ability, the power of the optics, but we had a certain amount of power to push the optics. We had a certain amount of availability of whatever. And so they would say, look, if we do these 2 or usually 3 legs within a greater metropolitan area, and in particular, if I'm using different data center providers and whatever, but I've got these different paths or whatever, that's resilient enough. And that gets ingrained in people's mindsets, like this is the way we do it. Back in the day, it was 2N, then it became concurrently maintainable and all these other things. And where we started our conversation, where you started talking about the edge has the ability to do the compute and the storage. It just doesn't have in the network. What I'm interested in as we look forward, first of all, we've got to change our mindset. Just like we do, you talk a lot about sustainability and other things. We've got to, as human beings, wherever we live in our world, like how are we managing our resources? In our industry, it's sometimes hard for us. I'm an old dog. I'm closer to 60 than 50, and I've been doing this for a long time in IT for 10 years and then in data centers for 20. That as new ideas come, I don't just reject them out of hand, that I look at them, we review them, we talk about them, we help them mature, and then apply them. I'm curious, as you imagine, I can see the opportunity that you're describing for as a service in future deployments that aren't deployed or they're lightly deployed now, where there's like literally physically the ability to be agile and deploy. But in the legacy stuff that's in downtown Chicago, New York City, Atlanta, Dallas, whatever, whether it's the facility itself or the surrounding area, it feels like not only is there disruption, but the difficulty in changing the old to the new would be pretty significant. So almost for a period of time, they wouldn't have to be the core it would have to be in these ancillary distributed areas so that we could, in other words, it's like retrofitting a ship. You got to pull the ship out of the line to retrofit it. So who's doing its job while it's being retrofitted and being put back into service?
Yeah, I mean, it's, right. I mean, it's the government's paying for all this. Two thoughts there. The government is paying to retrofit all this network. It really is to push, broadband to rural areas, but it makes it easier for us to route our bits. And we haven't got the satellite yet, which I think will completely change everything too.
Yeah.
And through beams that probably are, that I'm not sure that a lot of people are talking about, but it gives you more diverse network choices when you really don't have, you think you got a lot of choices, but there's not really that many routes right now. And that's a reason why, clouds like Facebook or, platforms like Facebook build their own fiber routes, because there's really not that many of them. So this whole idea of government focused and pushing broadband to rural areas is to really help solve that. I mean, it's a crime that some of these areas don't have access to broadband. I mean, how do you expect people to learn? And this is the whole digital divide. I mean, it's really out there, and it really is a huge problem. So it makes it very tough to better yourself when you don't have access to all this broadband and learning, because we just assume that, I have 10 gigs at my house. Everyone has 10 gigs, and that's not the case in the least bit. So it is imperative, we really need to get this broadband to rural areas so we can help people, better themselves, as opposed to, well, if that's their problem. It's not, it's our problem. So but because of that, the architecture of the network is going to change and how we interact it. And then you throw satellites in there, which I think, people still think Starlink, SpaceX is like this dish network where a cloud goes over it and, your whole service interrupted. The way they do it is they don't oversubscribe the network, meaning like an eyeball network oversubscribes the network, meaning that they can't assume you're going to take all 10 gigs at once, because that would make something impossible. So they assume that you're only going to use 20% of that. And that's how they build the network. If everyone goes to 10 gigs, they're going to limit you. They're going to throttle you. Right. No different than 5G as well. But kind of how we orchestrate this and how we push this data with Starlink now in space, and they undersubscribe it almost. So they're not going to let you put a Starlink terminal down until they know you can get that 300 or 500 megs of whatever service they promised you. And then it opens up this concept of, laser to laser pumps. So this is something that the military has been doing a long time. It's just coming to the commercial sense. I mean, I've been in the middle of the Atlantic in a submarine at 512K or 256K, sorry, on a 9-inch dish. Now that's with wave slap. And now imagine you have, a system that's dedicated or a constellation that's dedicated. And so instead of, let's say, routing to Ashburn, you could have an uplink, laser to laser comms to another uplink to a downlink. And so you're going to have this interesting mixture of the future, I think, of networking, which is no one's really talking about now. It's this mixture of terrestrial fiber with satellite capability with laser to laser that are going to route your bits. Ultimately, it's going to be better for us, but I think it's going to go outside these traditional areas. So Ashburn's the way it is because subsea cable. Right. That's where everything's built around it. Now, let's say you don't have to do that. I have my own uplink station that goes over to Europe, down to Frankfurt, and it has a downlink station there. So I think it's interesting to think, this other next layer of this network and how it's going to happen. And the satellite really is, they're spending gazillions of dollars, and the government's helping spending gazillions of dollars because that helps them too. Right. On this global communication to make it more resilient, but also pass the bits quicker.
Not just our government, governments all over the world, because when that packet gets to space, however slow it is to get up there, going through a vacuum, a lot of people don't understand. It is the speed of light, as opposed to being on Earth, where and they will show that, look, to get a packet from, for example, Des Moines to Chattanooga doing this, it's going to be slower. But to get to Des Moines to Singapore, it will be equal to or greater than in speed, faster getting to its destination than following the subsea route over there for these reasons. And so they're like, okay, so how do we leverage that? And that's early days. I've had Doug Money, who's the editor-in-chief at Satellite IT Bridge, on a few times, and we've talked about a number of these things. And in the beginning, I was like, Doug, you're crazy. But one of the things I loved about going to PTC is you hear about all these low Earth orbit stuff and all these things and the development that they're doing, not just for Pacific Islands, but they're coming to the, Eagle Falls, Idaho. They're coming to these Yeah.
They launch 40, I think it's like 40 satellites in each launch right now. And they want a constellation of like 35,000
Yeah.
satellites. And you have, Kuiper, the, competitor for SpaceX, between the two of them. I mean, it's going to change how we route bits.
Right.
And I think, we as a data center community tend to not think about that because we think in terms of monolithic fixed structures, and we're thinking in terms of how we support the large language learning models and AI. But in the future, how we route these bits and how we reach the customer, how the clouds are architected are going to be very, very different.
Yeah.
And we need to be thinking about that. I mean, we don't need to be changing how we do business now, but we should be looking how we're going to take advantage of that in the future for our business models, because it will be different. And in the end, the edge hasn't happened because the network's not there, but now we're funding it. The network is being funded right now, which will change how the edge is architected. What still amazes me is, you kind of talked about these regen huts, or these basically every 30 miles you have basically they increase the power of the optics so you can actually go further. But what amazes me is no one's taking advantage of those regen huts. I mean, you have cable, you have land, you have power. Why not put 8 racks for CDNs, the content-defined networks? And why don't you put stuff there like edgy, tiny deployments? You already have the space and land. Take advantage of it, monetize it, and because it's there.
When they can figure out how to do it, they will. But until then, if it's easier and less complicated and in their mind more easily understood to not do it, I mean, that's the, it will be curious to see how it develops. We're going to have a whole nother conversation just on satellites, because that's easily an hour or two, because there's so many things, both pros and cons. I am been listening to the conversation and talking to people in the industry for a while. There's so much opportunity, but there is there are some of the technology. What's the implication with the constellations? There are a number of things that are really interesting to me that we should consider. And so to give it its due, let's have that as our next conversation. And if let's do it again soon. But I want to tackle this, because you had referred to this before. You talk about the whole world in our industry. I say the whole world. Our industry talks about solving the large language model problem in AI with our big, massive data centers. My company makes really big data centers. There are a number of organizations like ours that are making these big data centers. And you have said before, wait a minute, so what about inference AI? Can you take just a minute to explain the way you understand it, what the difference between the two is, a large language model, and what role it needs, what infrastructure it would need versus inference? And why is it that you want to call our attention to this discussion?
Yeah, because all we're solving, when they talk generative AI, all you're really solving from, there's two parts of that, large language model and inference, or, how you interface with that language model and get the data out. LLMs can be anywhere, because all you're doing is to be honest, they don't 50% care about resiliency, 50 could care less if the whole thing goes down, because when you reboot it, it just starts up again.
Right.
And so what I think is interesting is some of these models will take 1 to 2 years to build, cost 40 or 50 million, have a bunch of data scientists and a bunch of compute going, but then they have to do something with it. Mm-hmm. They have to deploy that so the customers can interact with it. And that is definitely more distributed. If it's something like smart roads, smart cars, it is actually kind of latency matters on, if your car is steering you, do you really want that routing back to Ashburn to go to figure it out? So you are going to have to deploy this inference models closer to where the customer is, because a lot of this will be latency sensitive, meaning you type stuff in and you get a response, or it's machine to machine, where your machine has something, sends data to the thing. AI, the models gets it, looks at it, and sends it back to you. Mm-hmm. That's how you can control stuff. Mm-hmm. That's all going to be more latency sensitive, whereas the LLM is not different. Now, I also think it's interesting that LLM, they're standardizing on roughly 40 to 50 kilowatts for these large deployments right now, because it's they don't, just because you can go dense doesn't mean you have to go dense. Mm-hmm. Just because you can do 100 kilowatt racks doesn't mean you have to. The way the cloud thinks is space is infinite. Right. Like that's a data center problem. That's a QTS, a Compass problem. Right. What I want to do is make it cost effective for me. I want to make it operationally easy, and I want to spread customers, because I don't want a single row down to take down a bunch of customers.
Right.
So if I make a 300 kilowatt rack, I'm probably gonna have a lot of customers on that rack.
Right.
But if I spread it out, I'm gonna have less customers, less input, and that's not a me problem. That's a data center provider problem. So, now the inference side, they don't really know what that rack's going to look like. I've heard anything from standard compute size up to 15, 20 kilowatt per rack position. So I'm not sure if we're going to have to go as dense as we were on the LLM, but you're going to have to be distributed. This is really, you go look at NVIDIA's blog, they talk about it as edge AI. Mm-hmm. This is really the platform that we've been waiting for edge that's going to force everything to build. It's kind of convergence. You have this network that's being dispersed now, that as more companies take advantage of this network diverse routing, now you have a platform that actually needs that network that will have to deploy it. But where are you going to put this stuff?
Right.
They can, a lot of these sites can barely handle 6 to 8 kilowatts, and now we're talking 10 kilowatts plus. It's going to fundamentally change how we think about these deployments. And then on the LLM, once you make the model, guess what? You deploy the model. I mean, what do you do with that LLM space that you just that you have? I think that's also going to be interesting of how do they use that space. Do you make another version of that? Do you put another platform on that? Do you just have it idle? I don't know.
Right. Well, I've talked to a few of them. I'm going to work backwards. Just a response on that question. Excuse me. That exactly, because we've heard that a number of times, and I think it's fair for us to ask. So you build this big platform, you deploy it, it creates something. And once the it's basic training for a soldier or a cadet or a seaman or whatever. I've gone through my basic training. Now I'm released out into the world, and everything from here on is real-time learning. I sometimes will step out to go to an advanced class or go to a thing, but those are much smaller in scale than the original training that I went through on how to be a soldier and to operate legally in peace, war, and all these other things. But everything else is sort of this interaction. And so what they have said to us is, look, we've got these parameters, and in the same way that we deploy other platforms, when the role of this is exhausted, our intention is not to have to build more data centers or whatever, but that we'll be in a state of, we'll have different platforms deployed, and they won't all be doing necessarily the same thing at the same time, but that as platform 1 or 2 are reaching end of life, and platform 3 is accelerating, that we'll repurpose them and redeploy them. What I heard, Tony, is we're figuring it out. We're not sure exactly.
Yeah, it's definitely we're building the plane.
You're right. That's right. So we're figuring it out, but this is our intention. So okay, we're figuring it out.
One other quick thing to add to that on that subject too, but now you start getting into it. It's not just latency sensitive; it could be bandwidth sensitive too. So think hospitals on this, this platform that they're building, which basically looks at your MRI,
right,
goes to a database of 10,000 MRIs, compares it to actual results, and gives the radiologist, based on all this other stuff, what it thinks it is.
Right.
That's gigs and terabytes of data you're pushing. You want that on-prem because you sure as heck don't want to be paying that to go to Ashburn and coming back from Ashburn. Right. So that's kind of where it's not only going to be latency sensitive stuff. You're going to have high, lots of data you're going to have to push. You're going to want to push that close to minimize the cost of the network costs.
Yeah, it is always cheaper to compute a bit of data than move a bit of data.
That's artificial. It's the data gravity.
Yeah.
Who would have thought?
It always is. I know we just have a few minutes left. But it is, golly, it goes so fast. We can, so you alluded to this earlier, but I want to just put a fine point on it. Why do you think with these things that we're talking about, and well, we have experience. We're not the only people that are having these discussions in our industry or even our customers that are around it. Why do you think the edge, which seemed, whatever that means, and I've heard it described a number of different ways. I'll just say I think it's wherever the work gets done. And to the degree that we can push the work closer to the people that need the work done, we benefit in every possible way: cost, sustainability, performance, and security. Why do you think then, with that in mind, there's been a lot of words we say edge a lot. It's kind of like saying blockchain. We say it a lot, but
Yeah.
is there really? Why do you think it just hasn't caught on to the way that we think it should?
I think there's two things. A, the network was never there. You couldn't push it closer because the network just wasn't there. You kind of need this hub spoke to make it happen. You need the first hub to take all your front haul points and give stuff back. And if it needs to go back for the storage, it backhauls to that. We never had that kind of network, which is being built now, or, and that's not only through Bead stuff, but through other companies too. And you never had the platform. I mean, there's always been talk of these platforms. It's just, there's never been a platform that's needed it.
Yeah.
That platform now is generative AI.
Yeah.
We'll need that kind of approach to pushing this compute, so you interface with it closer to customers. I mean, you want ChatGPT to, like, when you type something in, to take like 5 minutes, you go get a coffee break. You don't want that. You want it quick. So it might not even be, you need it for actually the service to happen. It might just be, you want it for a great customer experience. How annoying is when you're on Netflix and stuff and you hit pause and, it feels like a minute later it finally pauses, or you hit fast forward and it feels like it doesn't stop where you want to. That's all latency.
Right.
Imagine that when you're interacting with this model more times, it's going to frustrate you even more.
I was trying to explain this to somebody. I think that's a great answer. I am so glad that just like building the highway infrastructure, it required both the public and the private oomph to get it going, and the private network or the private market to see the value. And once they did, then it was Katie bar the door. I was explaining to one of my daughters who's in her mid-20s, and I live in the Atlanta area, and I said, imagine a day when you have a Jarvis on your wrist or on your device or whatever, and you've gone to a show, you and your sister, or you and your friends, and it's midnight. Wouldn't you want something that's not just like a ChatGPT, but is like, Caitlin, I'm watching these characters around you, or I can detect a heat source in the parking garage, or whatever. Like, this is your Sentry. It's not just your personal assistant to make sure your tickets get bought on time, but it can see the weather report, and that, if we don't change our flight now, we may get delayed or whatever. This actual intelligent thing, and that can give me real-time information that is super important to my health and welfare and the things around me. And I think you've alluded to it or spoken to it directly a number of times. Real delayed, there's somebody waiting on the 3 steps up. And I realize we're a ways from this, but if I'm a tech walking through a facility, if I'm just a security guard out in Des Moines, and I'm on my just regular rounds, and I've got something that can help detect a chemical anomaly before anything else can detect that fire or smell something or whatever. I want it real time. I don't want it 5 minutes later or 8 minutes later.
Yep. And I think, yes, it is in the future, but we need to understand where we're going so we can build for that.
Right.
We need to help, usher that along. If you don't want your business to be irrelevant, you need to make sure that, in 5 years or 10 years that this is kind of going to happen, and start having a plan, your 2030, 2035 plan, meaning that these plans need to take advantage of this technology. What future state's going to be, you're going to be irrelevant.
Yeah.
So, I think, yes, edge is there. The network is not there, but it will be. Inference is not there, but it will be. So how are you building your service, your company, your business to take advantage of that? Because it will happen. And this is not only, it's not only private funding, it's public funding as well. The DoD and, federal and everyone's government wants this as well for their own applications. Whether it's building Skynet or something else, it will happen. So, I think you have to look, things will change. Yeah. And how do you take advantage of that, or you will be irrelevant?
Yeah. Well, I love your newsletter. I'm going to make sure we put it in the link notes below, because you comment on a wide variety of topics. This is one of them.
It's my way to ramble about energy, technology, and of course, something near to my heart, kind of veterans and why we should be hiring more veterans.
I would sum it up as human flourishing, right? I see you comment a lot of things that I've enjoyed reading, and they're not long reads; they're brief reads to to be intriguing and to challenge us to think about it more. And whether we come to the same conclusion as you, I love that you take a few minutes. It's not your primary job, but it is near and dear to your heart, and you publish them. And I really appreciate you coming on the show today. What haven't we talked about in this conversation that we should have already?
No, I think it's, on those newsletters, I'd have a different perspective. I didn't grow up in the data center industry. I grew up in submarines. So I don't have, it's sometimes good that I don't have the baggage of 20 years of that, because I challenge stuff and say, why do we do that? But it's sometimes bad because I make stupid, or I say stupid things because I didn't know it. So, I just, I think it's interesting, but I do think we need to be more forward looking on how the network's changing, just to get ahead of it. And that's the same thing with power too. We need to be forward looking on the power, but honest with ourselves.
Right.
Like NewScale was a great example of, you have to be honest with yourself about timelines of what this is going to be to take advantage of. If you're depending on an SMR now, can you wait to build a data center for the next 12 or 13 years? Because that's what it's going to take.
Right.
And, right now, time to market matters. We even think a year is too long. So,
right.
Yeah, I wouldn't be planning too much business on it.
Right. If you're building your 2035 plan in 2034, you're probably in trouble. So,
yep, 100% agree with that statement.
Tony Grayson, thank you for coming on the show. We really appreciate it.
No, thank you for having me. I appreciate it.
Our great pleasure. Hey, if you like that conversation, click the like button. And if you loved it, subscribe. We'll see you next time, everybody. Take care.